Hello all. Today in this video lecture we will see numerical 9 on resolution of forces chapter and subject is engineering mechanics. So in this numerical our objective is just before that see this figure, this A dash axis and this B dash axis, and let us consider this point as O. So at point O there is 200 Newton force is acting. So here see this 45 degree angle, alpha degree angle, beta, those are given quantities. But alpha and beta are not necessary. Like with the help of alpha and beta, it's difficult to find out components. So we need exact degree like 45 degree, 30 degree like this. And here our objective is to calculate this alpha, and along A dash this component, let us consider this as F1. So F1 component is given, it is 150 Newton. So this F is 200 Newton. Let us consider this as F. So our first objective is to calculate this alpha, and our second objective is to calculate this F2 component. This is second objective. So before that we all know that F1 and F2, see those are oblique components. So for calculation of F1 and F2 we need this beta and alpha angle. So with the help of geometry, this geometry, we will calculate alpha and beta. Then thereafter we will calculate first with the help of F1 component formula. We will calculate alpha first, and then thereafter we will move towards F2. So just see how we will solve this numerical. So this is, and this F2 will be our objective, and given quantities are this F force 200 Newton, this F force 200 Newton, this F1 150 Newton. So here see this B dash line like this. So that means it is 180 degree. B dash axis is 180 degree. So, and first I will calculate beta. So beta is equal to this B dash 180 degree, and this three angles, see 45 degree, alpha and beta. So whenever we minus 45 degree and alpha from that 180 degree, then we will get beta. So 180 degree minus 45 degree minus alpha. So beta we will get in terms of alpha. So 180 degree minus 45 degree, it is 135 degree. So this beta we calculated it in terms of alpha. Just this is, consider this as first equation. So now our first objective is to calculate this alpha. Alpha, that means directly value of alpha in digit, like 35 degree, 42 degree. So we will calculate this. So what we will see, we will take formula of this F1 component. See component, although it is given quantity, but in F1 component there is alpha. So and see, this F is also given quantity. So this alpha we will find through that formula. Component, oblique component F1. So F1 is equal to F multiply by sine of. So now we took F1 oblique component formula, but always remember that in denominator which angle will come here, in denominator between force F and F2 angle, beta angle will come, and beta here in equation 1, see 135 degree minus alpha. Just put beta here, and in denominator both angle will come this. Between force F and F1 alpha and between force F and F2 beta. Alpha plus beta. So equation 1 becomes, just take this here, beta is equal to 135 degree minus alpha. So put beta in this above equation, sine of 135 degree minus alpha upon sine of alpha plus 135 degree minus alpha. So this F1 is also given quantity. See here, this F1 is 150 Newton. 150 Newton is equal to F is 200 Newton multiply by sine of 135 degree minus alpha upon, see this alpha will get cancelled because this is plus alpha and this is minus alpha. So remaining only sine of 135 degree. So here mathematically what will happen, 150 upon 200 equal to sine of 135 degree minus alpha sine of 135 degree minus alpha upon sine of 135 degree. So see here, just see sine of 135 degree minus alpha is equal to 150 upon 200 into sine of 135 degree. So solve this with the help of engineering calci. This 150 into sine of 135 degree divided by 200, it is 0.5303, and this sine of 135 degree minus alpha. So what we will do, we will take this sine to this side, then what will happen, this will sine inverse 0.5303, and only here remaining will be 135 degree minus alpha. So let's take new slide. Sine inverse of 0.5303, it is 32 degree. (135 degree minus alpha). So alpha is equal to 135 degree minus 32 degree. Just I am solving it mathematically. Just see, 135 degree minus 32 degree is equal to 103 degree. So this is alpha. So equation 1 becomes, this is equation 1. Equation 1 is beta is equal to 135 degree minus alpha. Here alpha is 103 degree. So 135 degree minus 103 degree it is 32 degree. So we calculated both alpha and beta. (103 degree and 32 degree. Alpha is 103 degree. And beta is 32 degree. So now our next objective is to calculate this F2. So this F2, just we all know that formula of component, oblique component. So just use those formula, and with the help of this formula we will calculate F2 component. F2 is equal to F sine of angle between F and F1 alpha upon sine of alpha plus beta. So this F2 is our objective. F2 as it is, F is 200 sine of alpha. Alpha is 103 degree upon sine of alpha plus beta. 103 degree plus beta is 32 degree. So 200 into sine of 103 degree, it is 0.9743 upon sine of 135 degree, 0.7071. So this F2 will be 200 into 0.9743 upon 0.7071. It is 275.576. And unit, see this, F is also in Newton and F1 is also in Newton, so unit is same, Newton. So our second objective also completed. So initially in this numerical, given quantities are this A axis, BB axis, and this basic geometry, and this at O point there is one 200 Newton force, and one oblique component is also given, F1 component 115 Newton. So initially with the help of those geometry and forces we calculated beta in terms of alpha. Then thereafter we took F1 component or formula. F1 component formula, we insert all values in F1 component, and due to F1 formula we get exact alpha value in degree, it is 103 degree, and beta we took it initially, later we insert this alpha value in beta equation, then we get beta also. And component F2 directly we solve with the help of F2 component formula, because we had all values. So that way we solve this numerical. See, those mathematical steps are important. The sign will get, this left hand side sign will get to right hand side. So what will happen? Sign inverse. So the solving methodology is important. So thank you very much.